Okay, look at the time wrong. No wonder we were rushed at the end. Okay, we still have a good 20 minutes left. Most people are gone, so I'm going to do the video. People will know where to find it. Okay, I'm just going to expand on what I said about polynomials and maybe do this a little more. Okay, the zeros here, for reasons that I just explained. Well, if x is 6, if x is -3, if x is 5, then one of these is going to be 0, right? So that's going to make y 0. Zeros mean y is 0 means we go through the x-axis. So the zeros are at -6, -3, 5. Y-intercept is when x equals 0. So we just plug in 0 and declare we get -6 times 3 times -5. And that's -90, and then times 4 is -360. Now, I'll be a little more explicit about what happens if x is a large negative number, but if we've got a big negative x, and all three of these factors, x minus 6, x plus 3, and x minus 5, are all big negative numbers. So y equals 4 times x minus 6 times x plus 3 times x minus 5. Well, this is negative, this is negative, this is negative, and they're all big. If you multiply big numbers, you get a bigger number, and if you multiply 3 big numbers, you get an even bigger one. So this is a really big negative number. I should also notice that the 4 here is positive, so that isn't going to affect the sign. So this is a really big negative. Okay. So I'm going to write it this way, just to contrast with this way. Could have done something similar. I could say that all positive, positive, positive. They're all positive, mixed positive, right? And they're all big, so it's going to be really big. Well, I'm just going to write this as 4 times a big positive times another big positive times another big positive. And that's a really big positive. So our graph is going to look like this. So you can just summarize what we have here. Zeros at -3, 5, and 6. We have a 0 here. Let's say that -3 is here. And let's say 5 is here. And 6 is here. So the graph has to go through these 3 points. Because if x is -3, that gives you 0 here. So you'd have -3 and y is 0. That's a point where x is -3 and y is 0. Similarly, if x equals 5, then x minus 5 is going to be 0, so y is going to be 0. With x equals 5, then y is 0, so we have the point 5, 0, etc. Same with 6. Okay, the x-intercept, I said it was -360 because I have one too many negative signs in my feeble brain. Okay, but obviously negative here, but these are both positive. We're going to get a positive. Okay. It wasn't going to work. It was negative. This one's just not going to work out with these conditions. In any case, it works out. So we have 360. And that's the Y-intercept. A big negative gives us a huge negative. And that means that the graph, after we get through here, moving to the left, is going to rapidly decrease. Okay. The fact that if y is a big positive number, if x is a big positive number, it means we're over here and we get a really big positive number. So it's going to go up really rapidly. So now if we want to sketch our graph, where'd all my charts go? We want to sketch our graph. There it is. Okay. Got to go through this point, this point, this point, this point, which means it's going to come up like so. So we're going to turn around about here and come down a little below the axis and go back up. So here is our graph of y equals 4 times x minus 6 times x plus 3 times x minus 5. Now, it's not a totally accurate graph. It's probably not too bad, okay? And that's really all there is. Now, there's more. You know, what if this was squared or this was cubed? Okay, you're going to have to, well, actually, move it on. I think I've got time to do that, okay? So that's the fundamental thing you want to understand. The other thing that I mentioned quickly at the end of class is that the polynomial is in this form, you want to put it into a form similar to what we see here. And that's probably going to be really difficult to do for this polynomial. For some polynomials, it's easier, but you got to be able to do the factoring and long division. And that comes along a little bit later in the chapter, but we understand that if we have this, we can generally put it into a form something like this and get a handle on its graph if we can do that. Okay. I don't know if there's any more clean boards, so I might have to clean something here, but let's see. Okay, now let's find the equation of a polynomial. The polynomial has a 0 here, a 0 here, and a 0 here. Now we could have more than 3, which would just make the polynomial that much weightier. It would wiggle more. And we'll see how that works. It's pretty obvious. So let's just say this is -4, 0. And this is 2, 0. And this is, let's say, 7. So that's not quite scaled, but it's okay. All right. And let's say we know that it's down over here. So let's actually reverse this because let's say it's down here. So if we go to the left, it goes up like here, and then it goes down here. Now, I'm going to ask you if you don't mind. Just sketch 3 points like this and come down from here and then go through this 0, through this one, and through this one, and see what you get. See what it looks like. See if you're getting this. And if you're watching this on video, do that. See if you can sketch something much like what we've done. It goes through these points, but it's up over here and down over here. Whereas in our previous example, it was down over here and up over there. Okay, so everybody, pretty much did that quickly. Which is good if you don't have a lot of time. So something like that. Now it looks a whole lot like what I saw you draw. Everybody drew that. Okay, what do you notice about the y-intercept? Is the y-intercept positive or negative? Just give me positive or negative. It's negative, it's down here. That's negative y value down here, right? So okay. Now, I'm going to let you decide what the y-intercept is. Okay, I asked somebody to tell me what the y-intercept was. I gave examples, maybe -2, -7,883, -250. Can't use a positive number because you know it's got to be negative, right? Now, first answer I got was -2. If I hadn't said -2, that would have been a good choice. Can't repeat what I've said. That's an implicit rule. Okay, you're forgiven because you then said -4, and that's just fine. Okay, and you're never in trouble for that anyway. Okay, so we have 0, -4. Okay, now, first thing we're going to have is y equals something times x minus, well, x plus or minus some number, and x plus or minus some number, and x plus or minus some number. What three numbers do we have to put in here if we're going to get y equals 0 when x is -4, 2, and 7? For example, what can I put up there that would make this thing 0 when x is -4? So we'll pause the video for a second. Okay. Now, I want to put something in here so that when x is 2, I get 0, right? So just like I put a +4 here so that when x is -4, we get 0. Don't say it, but gesture it. Yeah. Okay. I think I saw. Think about it. What do you think? I'm going to tell you. I think I saw it. I mean, I saw a negative, and then I saw something loopy. And it looked a lot like the 2. And I'm pretty sure that's what I answered, so I'm pretty sure that's what you meant. Okay. You could have gone -2. That would have been even more explicit, but I believe you. Okay. Totally believe you. Okay. Okay. Now, write down what I would put here if I want to have 0 when x equals 7. Okay, so if I want a 0 when x is 7, then I'm going to put a -7 here, so when x is 7, that gives me 0. Okay. Now, I'm going to put A out here. And A is not a backward apostrophe A thing. Doesn't mean your particular, your personal A value. It means just an unknown. Okay. So if x equals 0, what is the value of y? Write it out. Okay. So if x equals 0, y equals what? Well, we're going to replace x by 0. A times 0 plus 4 times 0 minus 2 times 0 minus 7. Excuse me. Allergy season. And of course, that means you have A times 4 times -2 times -7, which equals 4 times -2 is -8. Multiply that by -7, you get 56. You get 56A. Okay. And you're on track to get that. I think you understand, right? I'm not sure you do. You're even more on track when I look at you. So everybody's on track. Okay. Now, y equals 0. I mean, when x equals 0, that gives you the y-intercept, right? The y-intercept is at 0, 56a. Okay. Well, what is the y-intercept according to our graph? It's at 0, -4. Y-intercept is 0, -4. So, can you tell me what A had better be? Okay, there's a certain type of thinking you really want to have in mathematics, and you know it's a stretch for people at this point of the course. If your y-intercept is at 0, 56a, and your y-intercept is at 0, -4, well, this is the y-intercept, and this is the y-intercept, right? So we can say 0, 56a equals 0, -4. Now, that means the first coordinate has to be the same, right? Well, it is because first coordinate 0, first coordinate 0. The second coordinate also has to be the same, right? Now, if 56a is the same as -4, then what does a have to be? Okay, well, say that 56a is the same as -4. Means that 56a equals -4, right? Now that's a simple equation. What do you do to both sides? Just solve for a. Okay. Glad to see everybody wrote out the algebra correctly. Okay, well, you have 56a. You divide that by 56, it's going to leave you a. And that's -4 over 56. And -4 over 56 is -1 over 14. Okay, so if a is -1 over 14, the zeros are what they are. And the y-intercept matches what somebody chose the y-intercept to match, right? So now the equation is this. So 1/14 times x plus 4, x minus 2, x minus 7. Okay. We could even estimate using this equation over coordinates to this point. Makes sense. Now, they probably aren't real close, but given my superior artistry, they have to be really close, right? Hell no, because it's really hard to draw these things, okay? Really hard to draw them with a great deal of accuracy. Now, you notice that we're 8 minutes over the actual scheduled time, so if you need to go, just stomp out, okay? That take us just a minute to finish this up, and I want to have this on the video. You don't have to be here for it, but you gotta go. But you're welcome to stick around for a few more minutes. If I estimate the coordinates of this point, if this is 2 and this is 7, this is about halfway between 2 and 7, right? Halfway between 2 and 7 is 4.5. Up here, well, if this is -4, then +4 would be here. That looks like about maybe 5.5. So the coordinates at this point, maybe 4.5, 5.5. Boy, I am a whiteboard space. If I plug in 4.5 for x, then this equation here should give us something fairly close. 5.5. Well, I can kind of do that. I'll do that. Let's Capping green over here. Okay, so okay, well, we just plug in 4.5 here and do the arithmetic. Now I'll do it in my head, so I'm sure to be wrong. 4.5 minus 2 is 2.5, right? 4.5 minus 7 is -2.5. So 2.5 times 2.5 is 6.25. But then this is a -0.5. Uh-oh. We're in big trouble. That can't be even close to right. That's really screwed up. What's wrong? Okay, -4.5 plus, no, that's right. 4.5 plus 4. It's 4.5 plus 4, not -4.5 plus 4. Okay, I'm with it again, I hope. So this times this gives us 6.25 if you do the arithmetic. And this is 8.5. 8.5 times 6.25 is about 54 or 55, okay? Now, I don't have that done accurately, but I'm going to say this is about 55 over this is positive and this is negative. Okay, it's 55, -55 over 14. That's pretty close to 4 because 56 over 14 would be 4. I estimated it'd be 5.5. Just means I got a little carried away when I drew my graph. Maybe I estimated a little high. Okay, but it's plausible. So I say it's hard to draw these with a great deal of accuracy. You never really know how high it has to go. You have to use calculus to figure out how high that thing actually goes. It's fairly easy to do if you know a little calculus. Okay, but yeah, it's pre-calculus. We're not there yet. Anyhow, that should at least tell you it's plausible with this graph is a reasonably accurate depiction, but you can't use it to make exact estimates. Okay,